Digital twin segment, let's look at the behavior of DTS language. In DTS, an action is called a segment. Segment is a basic unit of modeling a system. Behavior is defined as a commandable or observable unit of an element of a system. It enables causal connections between actions. Now let's take a look at these actions. Let's take an action called mySegment as an example. This behavior has another child behavior inside. Behaviors of the children have a causal relationship. In DTS, the system is modeled with causality, and everything is designed with a single criterion of behavior. One action can be started or reset by another action, and this result causes another action. By causally connecting these actions, the action network is constructed. This is called system causality modeling in DTS. Now, let's look at the two types of behavior. Although the basic structure is the same, but there are some different characteristics. These two types are said to be calling behavior and actual behavior. Let's look at the differences one by one. First, the calling behavior is placed inside the actual behavior. It can be said that the actual action calls the calling action sequentially. Second, the calling behavior constitutes the input-output with the actual behavior. The actual behavior is the same as being positioned as the start, reset, and end values of the calling behavior. Third, the calling action passively follows the actual action's command. This is the same as the actual action makes the call action active. Fourth, the calling action does not define internal causation in detail, but actual behavior is remembered as a value by calling internal causality exactly. Now, let's see how the two types of behavior are used through examples. I have my action. This behavior is causally linked to 5 internal behaviors. Now, the type of internal action number 1 is a calling action, which can also be seen as a process of my action progress. If you look at the input-output behavior of call 1, it has a structure to observe BC by instructing external system behavior A. This is equivalent to saying that though we do not know the detailed causal relationship between ABC actions, we know that BC is observed causally by instructing action A. ABC behavior is the actual behavior of different systems, and it is expected that there will be another causal relationship between them. Although we do not know the detailed causality of the call, we understand the characteristic that the result can be observed by waiting for a certain amount of time after the start instruction. There are 3 types of input-output of actual action: start, reset, and end. If all input-output can be instructed and observed, it is called a normal interface. If the actual behavior cannot be instructed to execute, it is said that the cause of its direct start and reset is unknown, and this behavior is said to be a non-commandable attribute. If the termination is unobservable, it is said that its result is unknown, and this behavior is said to be an unobservable attribute. All systems are likely to be modellable with real-world behavior, but because of these uninstructable and unobservable properties, we use non-causal behavior. Continue.